It's time now to learn about quadratic functions. Quadratic function can be written in the form of f of x is equal to ax squared plus bx plus c, where a, b, and c are constants with a not equaling 0. The domain of a quadratic function is all real numbers. The graph of any quadratic function is a parabola. A parabola is a U-shaped graph that opens either upward or downward. Here are the basic characteristics of a parabola. The vertex is the lowest point on the parabola when it opens upward. The vertex is the highest point on the parabola when it opens downward. The axis of symmetry is a vertical line that passes through the vertex, but it is not a part of the parabola. The left and right sides of the parabola would match if we folded the XY plane along the axis of symmetry. Use the graph of the quadratic function to identify the vertex, axis of symmetry, and whether the parabola opens up or down. F of 0 means the x value is 0, so go down to where you hit your y value, which is -2, and f of 2 is also -2. But we want to find the vertex. So the vertex is at the lowest ordered pair, which would be 1, -3. The axis of symmetry, abbreviated AOS, is this dotted line. It is a vertical line. Vertical lines are in the form of x equals. So that is x equals 1. And the parabola opens up. Let's look at example 2. We'll go ahead and find 2 points since it's asking us to find f of 0 and f of 3. The vertex is the highest point at 2, 4. The axis of symmetry is the x value of your vertex. X is equal to 2, and this parabola opens down. In order to graph a parabola by hand, it is helpful to know the location of the vertex. This is the key right here. X is equal to -b over 2a. That is the axis of symmetry. It is also the x coordinate of the vertex. The vertex is written as an ordered pair and is labeled HK. But understand the x value of the vertex is the same number you get when you plug in -b over 2a to find the axis of symmetry. To find the y coordinate then, you take that same value and you plug it back into your function. The parabola is going to open up if a is positive and open down if a is negative. So I'm going to share my screen with you for a second, and we're going to look at a graph. We're going to look at Desmos. So what we have on the screen is y equals x squared. And then if I graph y equals 0x squared, you can see that is a straight line. That is why the condition has to be that a is not equal to 0, because if a is equal to 0, you don't have a parabola, you have a straight line. And then the next graph is I have y equals ax squared, and I have a slider for a. So watch what happens as a gets larger. You can see that we have the red parabola, and that it is wider, or a vertical compression, compared to y equals x squared, which is the black graph. And then as a gets larger, you can see that the red graph is inside the black graph, which is narrower, or it's also a vertical stretch. And then as a becomes negative, we can see that our graph is flipped, or it opens down. So when a is between 0 and 1, our parabola is wider than x squared. And when a is greater than 1, we can see that the parabola is narrower. All right, hope you enjoyed that. All right, so let's do some calculations here. Find the vertex for each graph. There is a system to do this, and if you do the same thing every time, you will get the correct answer. I'm always going to list A, B, and C. Next, I'm going to write x is equal to negative b over 2a. I'm going to calculate this, and x is equal to 4. That tells me the axis of symmetry is x is equal to 4. It also tells me that that is the x value of my vertex. So now I need to find the y value. To find the y value, we are going to find f of 4. Take 4 and substitute it in the original. So our vertex is 4, negative 23. Let's try it again. A is negative 2, B is negative 4, C is 1, x is negative b over 2a is the axis of symmetry, as well as the x value of our vertex. So the x value of our vertex is negative 1. Let's find the y value. So let's find f of negative 1. So the vertex is negative 1, 3. I will let you read that. So we have a minimum value when the parabola opens up, and we have a maximum value when the parabola opens down. Find the minimum y value on the graph of f of x is equal to 3x squared plus 12x minus 5. So it's asking us to find the vertex. Now we want to find f of -2. So our vertex is the ordered pair -2, -17. But we want to find the minimum y value. So the minimum y value is the y value of the vertex. So our answer is -17. In the next example, we want to find the maximum. So a is equal to -2, b is equal to 1, and c is equal to -10. We know that our a value is negative, so we know the parabola is going to open down. So if it's going to open down, it's going to have a maximum y value. Don't let fractions scare you. You have a calculator. I would substitute in 1/4 for x. And I can do this on my calculator. And I get -79/8. So the vertex is at 1/4. And since the question is asking to find the maximum y value, the y value of the vertex is -79/8. One way to graph a quadratic function without a graphing calculator is to first apply the vertex formula. After the vertex is located, a table of values can be made to locate points on either side of the vertex. We can also calculate the intercepts when graphing. We can find the x-intercept by setting y equal to 0. We can find the y-intercept by setting x is equal to 0. So let's practice graphing. So a is equal to 1, b is equal to -4, and c is equal to 3. We know that this parabola opens up. How do we know that? Well, we know that because a is equal to 1, and 1 is greater than 0. So that means it opens up. Does the parabola have a minimum or a maximum? Well, if the parabola is opening up, it's going to have a minimum. Next, let's find the axis of symmetry. So I'm going to put that down here. The axis of symmetry is x is equal to -b/2a. So x is equal to 2. Next, we want to find the vertex. So to find the y value of the vertex, we need to find f of 2. Which is equal to -1. So our vertex is at 2, -1. So I'm going to go ahead and graph that. Next, I want to find the x-intercepts. Well, to find an x-intercept, you set y equal to 0, which means we set our function equal to 0. And we can solve by factoring. So our x-intercepts are going to be at 3, 0, and at 1, 0. So I'm going to go ahead and graph those. And to find the y-intercept, we set x equal to 0. And that's always going to be 0c, because you put in 0 for your x's, you will have the constant. So if I graph 0, 3, now I know that this parabola is symmetric, which means I also know there's going to be a point at 4, 3. And now I will sketch in my parabola. It's not the best drawing, but I think you get the idea. If I wanted to draw in the axis of symmetry, then it would be this dotted line going through the vertex, but that is not necessary. There we go. All right, let's try it again. A is equal to -1, B is equal to -6, C is equal to -8. This parabola is going to open down because A is less than 0. If the parabola opens down, then it's going to have a maximum value. So to find the axis of symmetry, x is equal to -b over 2a. So x is going to equal -3. So to find the vertex, we're going to find f of -3. And that's going to equal 1. So our vertex is at -3, 1. To find the x-intercepts, we will set our quadratic equal to 0. I like to factor out a -1. I can divide both sides by -1 and it's gone. So I can factor this into x plus 4, x plus 2, set each of those factors equal to 0. And go ahead and graph those. And then the y-intercept, I would set x equal to 0. That will give me 0, -8. And then by symmetry, we can plot the other point. And now we will graph. And this one looks a little better than my last attempt. But there you have all the pieces. Example 3. We know that A is equal to -5, B is equal to 0, and C is equal to 1. Because A is negative, this will open down. If the parabola opens down, then it has a maximum. The axis of symmetry is x is equal to -b over 2a. Since b is 0, our axis of symmetry is x is equal to 0. To find the vertex, we need to find f of 0. When we plug 0 in for x, we get 1. X-intercepts, we're going to set the function equal to 0. We're going to use what we learned in the previous lesson. We'll subtract 1 from both sides, divide both sides by 5. We have x squared is equal to 1/5. We're going to take the square root of both sides, and we need plus or minus. And we can use our calculator to get a decimal approximation. So x is approximately equal to plus or minus 0.45. So in order to graph this, I'm not going to count by ones. I'm going to count by a half, so that each tick mark on the x-axis would represent a half. So this would actually be 1. And this one over here would be -1. So if I plot the x-intercepts, and I plot the vertex, when plotting a parabola, you need the vertex and a point on either side of the vertex. So we have that. And there you go. I will finish filling in our information here, our x-intercepts. And because our vertex was on the y-axis, the vertex and the y-intercept are the same. So you're asking, when am I ever going to use this? Well, here you go. Suppose that a baseball is thrown upward with initial velocity of 66 feet per second, which is 45 miles per hour, and it is released 8 feet above the ground. Its height h after t seconds is given by, this should be h of t right here, is equal to -16 t squared plus 66 t plus 8. After how many seconds does the baseball reach its maximum height? Estimate this height, round each answer to the nearest integer as needed. All right, if you want a picture of what's going on here, you have a baseball, and it starts at 8 feet above the ground, and the ball is being thrown up and the ball comes down. So there's my attempt to draw a picture. So we know that A is equal to -16. And by the way, -16 is gravity in feet per second. So you'll see that a lot. B is equal to 66, which represents 66 feet per second. In case you're wondering, it's 45 miles per hour. And C is the initial height at time 0 when the ball is thrown. We're going to do our same steps. X is equal to negative b over 2a. So x is equal to 33 over 16, or approximately 2.06. And since the directions say estimate and round to the nearest integer, the baseball reaches its maximum height approximately 2 seconds from the time it's being thrown upward. What is this height? Well, we're going to find h, and I'd recommend that we use 33 over 16 so we don't round and round again. And if we use our calculator and we calculate this, we get about, and if we round that to the nearest integer, the maximum height is about 76 feet. Hope you enjoyed this. There will be more. Until next time, do more math.